Good morning, everyone. My name is Li Jieming.
My name is Li Jisheng.
Throughout this presentation, we will be presenting our TIT6223 IoT fundamental case study, which is the smart medication reminder box under the healthcare category. The purpose of this project is to improve medication adherence by combining reminder mechanism, medication verification, and real-time monitoring through Internet of Things technologies. So without further delay, let's begin our presentation. Nowadays, many patients suffer from chronic illness and require medication at specific time every day. However, due to busy lifestyle, memory decline, or living alone, medication schedules are often forgotten. Traditional reminder methods such as alarm, clock, or mobile phone notification can only provide alerts, but they cannot verify whether the medication has actually been taken. This creates difficulty for family members and caregivers because they have no reliable way to monitor patient adherence remotely. In addition, the absence of digital medication record makes long-term monitoring and decision-making much more difficult. Therefore, our project focuses on three main objectives. First, improving medication adherence. Second, verifying medication taking behavior. And third, providing a real-time dashboard for caregiver and family members. To solve this problem, we developed an IoT-based smart medication reminder box. A normal alarm can only remind people, but it cannot tell us whether the medicine was actually taken. So in our project, we added two verification steps. First, the patient must press and hold the acknowledge button for 2 seconds. This helps prevent accidental touch and ensure that the user intentionally acknowledges the reminder. After that, the patient must open and close the medication compartment. Only when both actions are completed will the system record the medication as taken. If the user acknowledges the reminder but does not open the pillbox, the system records the event as still open pillbox. If no acknowledgement is received within 60 seconds, the event is recorded as missed. So all medication activity are automatically stored and displayed on the dashboard. Now, I will pass to Mr. Li Jiesheng to explain the system architecture data flow of our project.
This slide shows both the overall system architecture and the internal data flow of our project. We adopt a layer design because it makes the system easy to maintain, extend, and scalable in future implementations. At the input layer, the system collects information from the push button, door sensor, and the predefined medication schedule. Next input are processed by the medication controller SPC, which serves as the decision-making unit for the entire system. The controller validates the 2-second acknowledgement requirement, check whether the pill box has been opened and closed properly, and determine the final medication status. For communications protocol, we select the GPIO for hardware-level interactions, Wi-Fi for internet connectivity, TCP for reliable data transmissions, and HTTP for dashboard access through the web browser. TCP was specifically chosen because healthcare data should not be lost during the transmissions. Reliability is more important than transmission speed in this context. After the medication status is determined, the information is uploaded to the web server and displayed on the dashboard in the real time. Next, to evaluate the effectiveness of our smart medication reminder box, we conduct 100 event motor carrier simulations that represent different patient behavior and medication scenario. The results show that 69 events were successfully complete, 90 events was classified as missed, and 12 events were recorded as still open pillbox. An interesting observations from our analysis is the difference between morning and night medication sessions. Morning adherence reached 74%, while night adherence dropped to 64%. This suggests that patients may respond more effectively during daytime period and could require additional support mechanism at night. The statistics show how the IoT system can provide useful information for healthcare monitoring and decision making. Next, Ms. Li Jieming will explain the challenge, limitations, and future enhancements of our project.
Throughout the development process, we encounter several technical challenges. First, integrating multiple SBC, LED, sensor, speaker, and LCD display require careful synchronization and testing. Another challenge was ensuring reliable communication between medication controller and the web server. We need to make sure that medication record could be transmitted successfully without any data loss. Then, one of the limitations for our current design is that opening the pillbox does not necessarily guarantee that the patient actually consumed the medicine. The system can only verify that the medication compartment was accessed. For future improvement, we propose 3 enhancements. The first is a web-based scheduling system, so the caregiver or family members can change medication times remotely. The second is an email or SMS notification feature whenever medication events are missed. The third is support for multiple patient profiles, which making the system suitable for hospital, nursing home, and elderly care center. So we will now demonstrate the working prototype of our smart medication reminder box using Cisco Packet Tracer. In this demonstration, we will show three different scenarios. The first is scenario taken. The second scenario is fill open pill box. The third scenario is missed.
So this is our smart medication reminder box in the packet tracers. I will like to briefly explain our network design first. We separate the system into a private network and a public network to better represent a real-world deployment. The medication controller SPC is connected to a private home network through the home gateway. This represents the patient environment where the medication box operates locally and also securely. The web server is placed on the internal site and connected through the public router. The reason for this design is that caregiver may access the dashboard from different locations and devices, such as laptop, tablets, or smartphone. By pressing the web server on the internet, the dashboard becomes accessible remotely instead of being in limitation to the patient local network.
So now I will continue to demonstrate the three scenarios. So we will open the SPC to preset the reminder time. So now we stop the program and change the reminder time. So now we run the programming and it will show the status is ready and the LCD will display the system status. So now we wait for the medication reminder for the first scenario. So as you can see, the time we preset just now is aligned with the Malaysian time. So the morning LED and the speaker was function, which the speaker is sound and the LED was light out. The LCD will display the instruction for patient to take action. So for the first scenario is taken, so we need to acknowledge the button and hold 2 seconds. So it will show open pill box for the morning session. So we click for the morning door sensor and we close back. So the LCD will show medication taken, which is successfully recorded on the system and it will be later displayed on the dashboard. So as you can see, after we acknowledge the reminder, it will show on the SPC console as the status is recorded as taken. And we will continue wait for the second scenario, which is fill upon the pill box, and we set it as 12 and 26 p.m. So now the second scenario is arrived. In this scenario, we will like to demonstrate on the fill open pill box. So we just acknowledge the medication, but we did not open any pill box. So we just wait for the 60 seconds and the LCD will display medication fill. Alright, so the LCD display fill open pill box and the medication is filled. So inside the SPC console, it will record the second medication reminder, which is 12 and 26 p.m. And we have acknowledged it, but we did not complete the medication. And the status will record at fill open pill box. So for the next is 12 and 28 p.m. So this will demonstrate the missed status. So we will wait for this medication reminder. Alright, the third scenario is light up, and this scenario we will demonstrate the scenario of miss the reminder time. So we don't take any action at this time. Alright, the LCD display medication field. And inside the SBC console, it will summarize the timestamp for every day.
Alright, so once the medication event is complete, the medication controller SPC will create a medication record. The record contains the information such as the reminder time, acknowledgement time, complete time, response time, and medication status. The data is then transmitted to the web server SPC through the TCP communication on port 81. We selected TCP because it provides a reliable delivery, which is important for healthcare applications where the medication record should not be lost. Inside the web server SBC, the data is first received by the server, and the server will store all the medication events inside the medication log file. Next, the HTTP server read the stored information and publish it through the website. So now we will try to open the web browser to access our website link to view the dashboard for our smart medication reminder box, which is www.medbox.com. The dashboard will automatically refresh every 3 seconds, which allow users to view the latest medication information without manually refreshing the page. The dashboard also maintains historical record, which help to identify the medication taking patterns and support better healthcare decisions in the future. In conclusion, our smart medication reminder box successfully achieved all of its objectives. The project combined reminder mechanisms, medication verifications, network communications, and real-time dashboard monitoring into a complete IoT healthcare solutions. Unlike the traditional alarm system, our project not only remind users to take medications, but also verify whether the medication process has been complete or not. The dashboard provides caregivers with real-time information and historical record that support better monitoring and also the decision making. Throughout this project, we gain a valuable experience in IoT system integrations, communication protocol, dashboard development, and also healthcare applications. We believe that this system provides a strong foundation for future smart healthcare solutions and can be further expanded to support hospital, nursing home, and elderly care center. So that's all for our case study presentations. Thank you for watching our presentation.